fallout from an ancient asteroid collision to still reign on Earth. This report is from an anonymous astronaut. Extraterrestrial objects are constantly bombarding Earth. Thankfully, the vast majority are microscopic. Thanks to the planet's atmosphere, we live largely unaware of this celestial fusillade, which averages about 100 tons a day and mostly burns up long before hitting the ground. From the few that do make impact, researchers can gather clues about the composition of our solar system, with the goal of understanding how planets and other bodies emerged from an embryonic disk of dust and gas some 5 billion years ago. However, it seems many of the samples researchers have to work with originated from a single event that's been raining fallout for some 466 million years, giving us a biased picture of what's actually out there. Brief moment in time. At the moment, we seem to experiencing a fairly heavy rain of rocky meteorites called ordinary chondrites, which are distinguished by the presence of drop-like structures embedded in their bodies. Chondrites are further divided into 3 classes, H, L and LL, each thought to correspond to a different impact event long ago. We're currently seeing a disproportionate number of H and L type chondrites hit the Earth, but it wasn't always so. Researchers from the Field Museum of Natural History, the University of Chicago and Lund University in Sweden recently conducted an analysis of sediment samples from the Ordovician period, some 466 million years ago, to give us a glimpse of what was hitting the Earth at a very different point in its history. They collected their samples from a site near St. Petersburg in Russia, where the layers of rock are known to have built up very slowly, thus making it much more likely that a meteorite will be found in any given strata. A similar site in Sweden was responsible for the extinct Plana 065 meteorite discovered in 2016. We're doing space exploration with geological methods, essentially, says Philip Heck, the curator of meteorites for the Field Museum and lead author of the paper. The researchers then dissolved 600 pounds of rock in acid and sieved through the remains in the hopes of sifting out tiny grains of chromite, called spinels, delivered to Earth by meteorites. Analyzing the isotopic composition of these spinels allows researchers to classify the kind of meteorites they came from and take a kind of census of impacts at different points in the Earth's history. They published their work Monday in Nature Astronomy. Turning point. The time period the researchers were interested in occurred just before a major impact event somewhere in our solar system that delivered a hail of L-chondrite meteors to Earth beginning 466 million years ago. The bombardment was so heavy that it obscured nearly all other impacts in the geologic record for 1 million years, and we're still feeling the fallout today. Looking at a slice of time around 1 million years before the event, the researchers took a census of the meteorites that intersected the Earth's orbit and found that the cosmic rain looked very different back then. Instead of the L and H chondrites that we see today, a different kind of meteorite called echonrites made up nearly half of the micrometeorite impacts in the Ordovician. Anywhere from 10 to 29% of these were a type of echondrite that likely resulted from a massive collision on Vesta, the second largest asteroid in the solar system at over 300 miles in diameter. Echondrites are meteorites that appear to have been melted and reformed at some point in their lives, such as on Vesta, where molten lava flows likely reshaped the surface at some point early in its life. Today, echondrites are considered rare, say the researchers. In addition, there were many more LL chondrites and fewer H chondrites during the Ordovician. While the origins of these meteorites remain unclear, they likely result from periodic collisions among asteroids and other objects in the solar system, as well as gravitational perturbations from planets that alter the path of the millions of asteroids and other objects floating around the solar system. By just studying meteorites, we are likely to never get a balanced view of the solar system. However, says Heck, Not only did they find that our current barrage of meteorites was biased, but their results indicate that some kind of bias is always present. The composition of meteorites doesn't match the composition of asteroids, he says. Comet depends on what collision happened. We get different fragments from other sources. In other words, the heavenly rock showers that bathe the Earth give us only a snapshot of what the solar system looks like right now. For the full picture, we need to look elsewhere.
Get ready, people. The White House is officially worried about asteroids and comets smashing into Earth, making a surprising apocalypse plan announcement. U.S. government officials are working on perfecting an emergency plan designed to avert the risk of an asteroid/comet apocalypse. This announcement comes shortly after NASA spotted a comet that will fly near Earth in February. Earth is frequently impacted by smaller asteroids that are so tiny that they tend to burn up while entering Earth's atmosphere, passing completely unnoticed. However, there have been devastating events like the impacts of Chelyabinsk, Russia in 2013 and Tunguska in Russia in 1908, which destroyed around 2,000 square kilometers of land. The paper was written by the Interagency Working Group for Detecting and Mitigating the Impact of Earthbound Near-Earth Objects, aka Damien. Experts fear there may be little warning. Recently, the White House has revealed its National Near-Earth Object Preparedness Strategy, which aims to provide a solution to asteroids and comets that could impact our planet in the future. The idea is to sharpen our planet's alert systems and invest in futuristic space probes that could help us prevent an asteroid collision. The first and most important step is to improve our detection methods. That way scientists can alert defense experts about potentially apocalyptic NEOs or near-Earth objects. Furthermore, experts say we need to work on creating artificially intelligent space probes and pack them with high-tech sensors and lasers. To prevent a space rock smashing into Earth, experts plan to launch powerful rockets into the sky in order to intercept asteroids and calculate their approximate size and weight. Two of the most crucial details about potential asteroids in a collision course with Earth. After the space equipment gathers the data, defense experts can draw up a plan of action. This announcement comes shortly after NASA spotted a comet that will fly near Earth in February, reports the Sun. Disruption of the NEO may be required if there is little warning time, or if the object is very large. Technologies to deflect the NEO away from Earth can be used, but to either disrupt or deflect a very large object, research and development of high-energy solutions is required, wrote experts in the paper. After spotting an asteroid with a potential collision course with Earth, the next step is to alert the masses. The paper suggests that the U.S. should react similarly to a hurricane warning and declare a national emergency across every state. But what if you aren't in the U.S.? Will detection plans work? Even though the program will allow experts to detect incoming space rocks around the globe, it is still not clear if the U.S. will invest and prepare advanced technology to protect the rest of the planets. Contradictory harm. The strategy document lists 7 goals. Improve the country's NEO tracking and classifying abilities. Figure out how to move or blow up threatening NEOs. Make our models and predictions better. Come up with emergency procedures in case a NEO can't be deflected. Create warning systems and recovery strategies include other countries in our planning. Put together protocols and thresholds to use for quick decision